Hello everyone, this is Mrs. Ellsworth again. Look at this. Is it gold? How would you know? How could you find out? Well, density, of course, that's what we've been studying. Okay, this is the video number 2 to find the density of irregular shaped objects or else just really large objects. Okay, do you remember what formula that you'd use to find density? Okay, remember density equals the mass divided by the volume. The mass divided by the volume. So how do you find the mass again? That's right, with the electronic balance. Okay, and to reminder again, how do you find volume of an irregular shaped object? You can't use a formula like you did with the cylinders. So what would you use? You'd use a graduated cylinder. You'd use that instrument so you could do water displacement, right? Okay, so water displacement, just a little reminder on what you know about water displacement. We would use water displacement to find the volume, and okay, so here you take a reading of a graduated cylinder. Lots of times students like to put in their right up to the one certain line so it's easier for them to subtract and so that they make sure that they're reading it right. I don't care. I just pour in the amount of water and then I know that I can still fit in whatever object I'm going to measure. Anyway, so you go ahead and fill it up, take initial reading, then you go and you drop your object in it, and then the water level comes up. Whatever amount that comes up is your water displacement, and you find that by subtracting 60.5 minus the 50, and you would find out that the water displacement for this green jade sample is 10.5 milliliters. It's a nice diagram. Anyways, what if that piece of gold is too big and you can't find the volume that way? What would you do? Well, you could use bigger graduated cylinders because I've got a lot of them, but that graduated cylinder is not precise enough. Okay, each line goes to the 10, so you'd only be going one more decimal place beyond the calibration of 10, so you'd be going to the ones, and that just isn't good enough. So there's another way to do that. This isn't the first time that this problem has came around, so scientists have figured out another way to solve this trick. They would use water displacement using Archimedes' principle again, but this time, this right here, they filled up a beaker all the way to the tip top and it ran over. Then they go and put the object in, but then now whatever runs over, they catch it in another container. This water that displaced that piece of gold is going to be whatever water comes out of it. But we have a better way. I bought for our class some overflow cans, but I don't do it this way. Instead, I put this at the edge of the sink, and I put a graduated cylinder here so I don't have to go and then pour this again into another, from this container into the graduated cylinder, possibly losing some of my sample. So I put this full of water at the edge of the sink, and then I wait for it to quit dripping. Then I put my piece of sample in it, and then I catch that in a graduated cylinder so I can just measure the volume directly. This is pretty nice, but water has got a strong surface tension, so it isn't always perfect. So it's best if you can use a graduated cylinder directly, but again, if it's just too large, that isn't going to work. Also, with this type of specimen, you need to watch out that it doesn't hold bubbles inside of it and lose more volume that way. So, let's see what's next here. Oh, you're not done yet though, right? You've got to still remember, what are you trying to find? You're trying to find the density, not just the volume. The water displacement was for the volume. You found the mass with electronic balance. You found the volume with either an overflow can and caught that volume, or else you did water displacement with the graduated cylinders. And so then you divide the mass, divide by the volume, and don't forget, your units are in grams per cubic centimeters. And that's about as exciting as this gets. I will see you tomorrow in the lab. There was a question on your sheet. Make sure that you answer that. And I'll see you tomorrow.